Okay, Emily, what did you get?
I got 4.02 times 10 to the 24th.
4.02 times 10 to the 24th.
I got
Okay, let's work the problem, see if we are right. What did you say you got, Jamie? Did you say you?
I got 4.03 times
3.
10 to the 24th.
Okay, so if you got 4.03, it's still right, okay? And it's all a matter of rounding. All right, so we have, when I go in here, I highlight my keywords, molecules, and 6.7 mole sample of CCl4. So we always start with what we know, and that's the one that has a number with it. So 6.7 moles. I am a creature of habit, so I like to put whatever compound or element I'm working with next to it. So we are at the mole station, and we need to get to molecules. So for us to go from mole to molecules, we need Avogadro's number.
Yes.
But what goes on top?
6.02.
Avogadro's number, yes, 6.02
E to the 20.
times 10 to the 23rd molecules. And that is always in 1 mole. Yes?
Can we write E to the 23rd instead?
I don't care. All right, so I want you guys to look at this. This is over a naked 1, okay? And this is just like multiplying fractions. If you, so what we're doing is we have 6.7 moles times 6.02 times 10 to the 23rd, all over 1 times 1 mole. And this is particles. When I have a mole, I'm just looking at the units, and I divide a mole by a mole, what's that answer? 1. It just goes away. It's not even 1 mole. The mole crosses each other out. And we're left with a unit of particles or molecules. And we get 4.02 or 3 times 10 to the 24th.
I got 10 to the 26th.
I got 24. So you might look and see where you went wrong. Okay, are there any questions over that? Okay, yes.
So I got 4.03.
Oh, 4.03.
This one.
Okay, that's fine. It'd still be the same.
No,
I don't
so
know.
it
Oh,
could be-
mine is 4.03.
Okay.
But if you got 4.02 and you put that down there, that'd be fine. If you're dyslexic and you accidentally put 4.20, that'd still be fine.
So it just has to be like.
You're within a certain percentage. Okay? Okay. Now, let's go on. Today we are going to talk about molar mass, or it might be called molecular weight. And what this is, do not write all this down. What this is the mass of the element or the compound, and that is over 1 mole. So it's the molar mass, and that is in 1 mole. So everybody on the periodic table is in 1 mole, like we talked about yesterday. So if I had 1 mole of carbon, what would its molar mass be? 12.011 grams in 1 mole. 12.011 grams, and that is in 1 mole.
So you just do what we did yesterday and then add on the grams over mole. Multiply it by like 12.0.
Yeah, talk to me after class. I don't understand. So now what I've done is I've set up a conversion factor. All right, so for every compound has a molar mass. And that molar mass is always over 1 mole. But it's a conversion factor. And so we can always say the molar mass, which is grams over 1 mole. Or it can be 1 mole over however many grams it is, depending on what we're looking for. Like yesterday, we could flip Avogadro's number over 1 mole depending on what we're looking for. We're doing the same thing today. Yes?
Because you said don't write down all of it.
Yeah, I'll show you what's right down here in a minute. So what we're going to do is we are going to determine the molar mass of compounds, and we are going to use subscripts. So it might be easier when I get in there and I start doing the problem to make your notes. Okay? So, is everybody good with this and we just start doing a problem? Okay. So here is the molar mass. So here is C6H12O6. You see those subscripts. Those subscripts represent how many of those atoms I have. So I have how many atoms of carbon? 6. And of hydrogen I have? And oxygen there are?
6.
So we can take those and we can multiply those subscripts by the molar mass that is on the periodic table. And when we add all of those together, get all those products and add them together, we get 180.18 grams, and that is over 1 mole. But to say that, I just always go 180.18 gram per mole. So molar mass units are grams per mole. So that's how I figured out a mole of sugar. I took the formula for sugar, C12H22O11, and took all of those numbers, multiplied them by the mass for each element, and then added them up. And then went back, while I was at home, went home, took my scale out, and measured out 342.3 grams of sugar. So this is 1 mole of sugar. How many molecules are in this?
3. Oh, no.
How many molecules? How many particles?
6.
180. Oh, yeah, 6.02
6.02 times 10 to the 23rd particles are in this, which is 1 mole, which is 342 grams. So for water is 18.02 grams. This is in 1 mole, which means how many particles are in here?
6.02
Times 10 to the 23rd. Same thing with salt, 58.44 grams in 1 mole. And in 1 mole, there are 6.02 times 10 to the 23rd particles. All right, sometimes you're going to see something like this, where you have a compound, and what's different with this compound is we have parentheses, and then we have an additional subscript. So what we need to do with that additional subscript is we need to distribute it out to everything that is within the parentheses. So now we have CR, and we have one of them. We have N, and that is a 1. And how many N's do we have? The 3 distributes to the 1, and that means we have 3. And O, the 3 distributes to the 3, which means we have 9 O's. Once we figure out how many atoms of each one we have, we go and find their mass. CR's mass is 52. We multiply that by 1. Nitrogen's mass is 14.01. We multiply that by 3. And oxygen is 16, and we multiply that by 9. And then we add them all together. And we get the molar mass of CrNO3. Okay? So you must remember to distribute it out. Okay, so let's go to here. Find the molar mass or molecular weight for these three compounds. So NaOH. So the first thing I'm going to do is, I kind of write out what all I have. And then I go and I find the molar mass. Sodium, we're going to 2 decimal places, 22.99. And I only have one of them, so I'm just going to leave it alone. Oxygen is 15.999, so it's 16.00. And there's only one of them. And hydrogen is 1.01.
So how come sodium isn't 23.00 if you round it up to
22.990, because this is 22.990 versus 15.999.
Wait, so why don't you end up the 22.9?
What did what?
Why don't you end up?
Because I'm looking at my my third decimal place. My 0 cannot round up my 9, so I leave it 22.9. Whereas in 15.999, that third 9 rounds those up. All right, so now we add those together. 22.99 plus 16 plus 1.01, and we get 40.00. And our units are what? Grams what? Per mole, because this is molar mass. So grams per mole. If you on the quiz or test just put grams, you're not getting your full credit. So you have to put grams over mole. All right, so go work the next one. Okay, so if you would have put 23.00, your answer would have been off just a little bit by mine, but you still would get credit. It's all a matter of how you rounded. Okay?
So 100.11, you okay?
So if you would 100.11, would it be okay? Yes. Okay, if you are not getting my answers, raise your hand and let me know so I can come and help you. Number 6, or C, that is ALPO4. So that is AL, not AI. ALPO4. So Al is its own thing. That is aluminum.
So what
Yes.
should-
So what you can do is you hit second DRG and side, so go back to flow.
This should.
What's
No, but if your calculator is in scientific notation and you do put 1.00 times 10 to the second power, you'll get your credit. That's the same thing. What?
More work on it.
Why not?
Like that times 10.
Yeah. Anybody have a question? Yes. So yes, that would be your final answer. Well, I mean, it would be one question on a quiz or something. Huh? It would be like this. Find the molar mass of sodium hydroxide. Hold on. Yes.
Wait, so it will always be 10 to the mole?
If it's a molar mass, yes. Yes. That would be okay too. Yes. Yes.
If you ever rounded back to 122, would that be wrong?
Uh,
Or just round it up?
that would be fine. No, that would be fine. A lot of it might say to the correct significant figures or to the correct decimal place. So if I said to the correct decimal place, we're going 2 decimal places. So you could say 122.00. Still be right. Okay. Next. I'm not going to do these problems, but these problems are in homeroom. I just want to look at B real quick. So if I look at B, how many N's do I have? 2. How many H's do I have? 8. How many S's do I have?
2.
And how many O's do I have? 4. Okay? The 2 distributes to N, and there's an imaginary 1 there. And it distributes to the 4, and 2 times 4 is 8. And then S has a 1, and then O has 4. Okay, so now let's put this into a conversion factor. So we're going to hop on the mole train again. All right, so yesterday we're starting in this little place called Moleville, and we're going to call it MOL. And yesterday we went from molecules, Moleculeville, Particleville, wherever you want to go. And we were able to go to Moleville and back from Moleville back to molecules. So when I wanted to go from molecules to moles, in my conversion factor, what had to be on top?
From molecules to moles?
Yes, I want to go to moles. Moles has to be on top, so 1 mole. That means Avogadro's number, 6.02, times 10 to the 23rd molecules was on bottom. All right? I just added one in there, but I'm doing this thing right here. And then, if I wanted to go back the other way, if I wanted to go to molecules, this time Avogadro's number had to be on top. And on bottom was 1 mole. All right, so that's what you had homework over yesterday. Today, Moleville is like our grand central station. Everything we want to go to has to go through Moleville. So to get to from moles, today we learned about what, Trent? Huh? No, what did we learn about today? What did we just learn about? Mass. So if I want to go from moles to mass, or so grams, or this is going to be Massville. So for me to go from moles to mass, or mass to moles, there's a conversion factor. So what has grams in it and what has moles in it? What conversion factor that we just learned about? Molar mass. So if I want to go from moles to grams, what has to be on top? What unit? Grams. So the molar mass, yes. So the molar mass, and that is always over 1 mole. If I want to go back and I want to get to moles, that means this time 1 mole has to be on top, and the molar mass is on bottom. So your problems that you're going to see tonight and that we're going to do here in a minute, we're going to go from molecules all the way to grams.
And 1 mole is 6.02 times, right?
Not when we're talking about molar mass. You're just in 1 mole.
I know, but if you have your mole on top and your molar mass on bottom, you do like.
Let's work some problems and then you can ask the question. Yes.
So, if it gives you particles and it says go to mass, you do the molecule to mole conversion, and then you do the mole to grams conversion, or do you do all three at once?
No, you have to do two, go through steps. So we would set it up and we would go from molecules and we would go to moles by using 1 mole over 6.02. And then we would go from moles to molar mass by using molar mass over 1 mole. Okay?
The molar mass is like 15. You would do 15 over Avogadro's number. If you're trying to find how many moles.
At the very end, yes. And that's what it would look like. But I can't do the molar mass of 15 over Avogadro's number. It always has to be 15 over 1 mole. Okay, let's do the step and then see. All the homework, the answers are there. The answers are the little things that's out in parentheses.
Oh. Those in my equation.
Those are your answers.
That's
I did that the first
crazy.
time and then my friend told me that those.
I told you guys, I always give you the answer, stuff like that. Your answer is going to be either bolded or out in parentheses. So I know you know that you're doing it right. So if you get home and your answer is not answering mine or is not matching mine, then what you need to do is you need to get on a remind, take a picture of it, and say, what did I do wrong? Because I'm not getting that answer. And it might be that my answer key might be wrong, or I can go back and I can look at your work and see what you're doing wrong.
I put those numbers in my equation.
Yeah, then you probably did do it wrong. Yes.
Okay, that's not work on there.
Yeah, that's fine.
I just put the answer on it.
That's fine. That's fine. Okay, let's do a problem. We are just doing the mole to mass conversion. We're not taking it one more step. So just right here, how many grams of sodium chloride, so grams, are in 80 moles? So start with what you know. We know that we are starting with 80 moles. And I have 80 moles of NaCl. Everybody good with that? I am going to multiply that by a conversion factor, and I need to go from moles to grams. So what conversion factor do I need to get me from moles to grams?
From those, you put moles on the bottom.
Molar mass. So 1 mole on bottom, and we need the molar mass of sodium chloride.
Wait, okay, so that's
So 22.99 plus 35.45 gets me 58.44 grams of NaCl. Everybody understands where I got 58.44 from? I got it from the periodic table. The mass of Na plus the mass of Cl.
And then you just multiply that by 80.
And now we just take that and we multiply everything on top. 80 times 58.88. 4675.2. And that my units are grams, and that is of NaCl.
oh, so we have to put the thing.
I would get in the habit of just putting the compound or element there. Yes.
So we want to put grams for mole?
It is, for your answer?
Yeah.
No, because if you look here, moles divide each other out.
Oh, okay.
So we're left with grams. Get in the habit of crossing out those units. All right, let's do another problem. How many moles of CaCl2 are in 92.34 grams? So we had 92.34 grams and moles. So we start with what we know. 92.34 grams. We are getting to, we need to get to moles. So the only way for me to go from grams to moles is using what? What has grams and moles in it? Molar mass. So we need the molar mass of CaCl2.
110.98.
So that is 110.98. Does that go on top or bottom?
Bottom.
Bottom. 110.98 grams. And that is in 1 mole. Again, grams cross out. And we're left in moles. So you multiply everything on top. 92.34 times 1 gives me 92.34. And then divide by what's on bottom. 110.98. And that gives me
.83.
I'm just going to 0.83. 0.83 moles. Now, if you're one that has to go and write everything out, then go, by all means do it. If you need to write 92.34 times 1 over 110.98 equals 92.34 over 110.98 equals 0.83. Do it. You're not going to get penalized for putting more work in there. It's just hard for me to put all that stuff onto this one slide. You got what?
I did it inside.
Oh, okay.
Still correct.
Yes. Your answer was 0.832, you said? Or 8.32 times 10 to the negative 1. Still the right answer. Okay. Let's go on to a 3-stepper. I'm going to change A. Oops. I'm going to change A, and instead of saying moles, I'm going to say molecules. So let's figure out where we're going from. We have to get, our end goal is molecules. And we're starting with 75 grams. So write out what you're starting with. We are starting with
75 grams.
75 grams of NaCl. What's the next step? I'm in grams. I always have to get to moles. So how do I go from grams to moles?
Put grams on the bottom, and that should be 26.44.
Not 26.44. NaCl.
Oh, I put
Is it 58.4?
58.44.
0.44 grams. Does everybody know where we got the 58 from? Where did we get it from? Na plus Cl. My grams go away. I am in the correct unit for me to get to molecules. So for me to get from moles to molecules, what do I need?
Mole needs to be on top.
Mole is on top right now. I need to get from moles to molecules. What needs to be on top now?
Mole.
And what number goes with molecules?
6.02 times the 10 to the 24.
And that is in 1 mole. Again, Moles cross out, and we are left with molecules as our unit. And we needed to get to molecules. So we are in the correct unit, so which means we are ready to do our math. So now, those of you who like to visualize, 75 times 1 times 6.02 times 10 to the 23rd. And that is all over 58.44 times 1. I should be hearing calculators going, get me a number, get me an answer.
7.73 times 10 to the 23.
Yes, 7.73 times 10 to the 23rd molecules. If you didn't get that answer, then something is wrong, and I need to know, come and help you out. Everybody good? You want to do one more three-stepper?
No. No. Or more.
Okay, so what about the next problem, B? How many steps will it take?
3.
No, 1.
Molecules to mole.
Yes.
That we have how many stops?
3.
To go from molecules to mole?
Oh wait.
It's a one-stop, right? One-stop conversion. The up above is a two-step conversion. If you go to the next one, molecules to grams, or grams to molecules, how many stops? 2 stops. D, we have mass and molecules. How many stops? 2. Mass to moles, how many stops? 1. You need to be looking at that as you're doing your homework and making those conversions. So you have, what did I say, there's 12 problems to do tonight? 11 or 15, thank you. 15 problems. So I would start working that out, and I will come and help those who are still having problems.
It's still the one on homeroom, right?
It is still the one on homeroom. If you turned in that page and you need me to go ahead and stamp it so you can take it, then I can do that too.